Okay, in this video I'm going to show you various techniques with pipetting. First thing to note is what type of pipette you have. See here, this one is a volumetric pipette. No graduations, thick bulb. Notice there's a single line here. This symbolizes this will hold 10 mils and deliver it very accurately to within 0.02 mils. We have over here what's called a Moore pipette. See, there's no double line up there. There's just this bulb thing, and it's graduations. The graduations stop well below the tip, so that's 10. So you measure this guy similar to what you would use a burette, where you measure a difference. And here we have a serological pipette. You can tell because of the double lines up around here that this is a blowout style pipette. So you see marking 0, it stops here 9, maybe 9.5. So this tip is the whole 10. So when you eject that, you want to push that out. But the first step is, of course, to wash these guys. First step would be, I need some sort of soap solution. Now most desks have the soap solution already there. Most of these pipettes will not fit a scrub brush. So your best bet is either to pour this directly into it, thusly, or try to suck it up with a pipette bowl like this. I'm just basically trying to soak this and rinse this with the soap solution. Then I'm going to replace this with the water solution. You don't need to get this perfectly clean. Ideally, you've cleaned it when you're finished, but we are going to make 100% sure. As I rinse as much as I need to with regular water before we rinse with deionized water. So I'm gonna now suck up water, and we're trying to get rid of all that suds. It's okay if we pull too much. We're just trying to get it all gone. So it may take several rinsings, and feel free to, since this is deionized, it's not deionized water and it's not your analyte, you can use much more than you need. Maybe one more will be good. So notice if I break the vacuum, I get bubbles, and that could be problematic. That one's rinsed with the water solution. Now to rinse this one with the water solution. Okay, the next step is, of course, using deionized water. Now in things like this, you often have a wash bottle and you can squirt it in from the top. Once again, we don't need to fill it all the way up, but we do want to kind of replace the water with deionized water. Same thing here. From the top. I mean, I could fill a beaker and then do that. I'm rolling it around in here. Just try to coat all the sides with the deionized water, rinsing away all my regular water, all my ions left by the tap water. And finally, I'm going to turn this into the waste beaker. I want to rinse with a small portion of analyte. So today my analyte will be this red dye. So I'm sucking up a small portion, enough that I can coat the sides. Don't want to get this into the tip, into the bulb, but I'm letting that drain. This guy is ready to go. Do the same with my serological. And then I'll show you this serological technique using the pump. So I'm just sucking up a bit. Let this. I want to coat the sides as much as I can so that I'm kind of diluting it. Serological can sometimes leak, so okay. Now, one of the common bulbs is this type. You'll see it has this little dial that the chamber goes up, creates the suction through this here. As I want to release it, gently I'll release it through there. So here's an example of how to pipette up. Let's say 7 mils and put it into a pre-cleaned volumetric. So I could measure by difference, but since this is going backwards, I can do it like this. So I got this, so submerge to get 7 mils. Let's see if I can turn this. I want to aim for 3. So I'm going to twist the dial, making sure this is fully submerged, and I want to measure this so that it reads exactly 3. Right now it's just above the 3, so I'm going to play with the dial back and forth until I get the meniscus eye level as close to that 3 as I can. Let's move this. Might as well use this. Try to get that level with the camera. I think that's pretty good. So when I do this, this will deliver 7 mils if I fully empty this. So putting that into here, I'm going to depress this lever and just let it drain. Now, however, because this is a serological, all of this is considered part of the sample. So I'm going to go ahead and blow it out by fully depressing the whole knob up there. And by pushing that all out, I'm guaranteeing that is fully 7 mils. That is the way you would use the serological pipette. Now, to use a volumetric pipette, it only delivers 10 mils. The other type of bulb is the tri-valve bulb. We have the valve up here labeled A. When I press this, I can depress this bulb and it'll stay depressed. When I press the S, it sucks out of this bottom portion and creates the vacuum. And I press the E, I can slowly and carefully drain. So as I push this onto the volumetric pipette, the tip only needs to be in this region. It should not be in here, should not be way up there. If it's way up there, you've already damaged it. So, because if you push that valve, and you can push that valve up into here, you can no longer squeeze that valve. So I'm gonna just place this just in, so it's right there. Holding the A, depress this bulb. Submerge this fully in the solution. Make sure I have enough solution that can get 10, and I'm going to just press the S up here and let this fill. Let this fill. And so my goal is to get the meniscus, this up to the meniscus. So it's slowly filling. You'll notice that as I'm getting lower, I may have to hold this at an angle. If I get any air bubbles in here, if I break the vacuum, I may have to either drain it all out or try to add more in certain ways. Air bubbles are going to throw off your total volume. So almost there. If I overshoot it, I just feather the E back down. So we want it so the meniscus is right at the line. Come on, focus. Okay. I'm gonna nope, too much. So I did too much, and so I just hold the S. Okay, I think as good as that's going to get. And then for this, I'll move this down. We're gonna to the volumetric flask. So the tip, and I'm gonna just hold the E. I'm holding just the E, not the suction, not the A. I don't even need to compress the A. I'm just holding the E. That this has been calibrated to deliver just 10. Just 10. So if this is cleaned properly, that little bit at the tip is supposed to be there. That has been calibrated, so that is 10 mils. And that is how you're going to use a pipette. I'm going to demonstrate how to use this micro pipette. The first thing you should know, we got there's no tip to start off. You have a little dial right here that's going to change the volumes of the ejector, and we have our plunger with its first resistance, first stop, and second stop. Now, the first thing to note is that when we're using one liquid, we only need one pipette tip. But if we were to get multiple different liquids, we would switch tips between pipettes. So I'm gonna, from the resting position, so it's not even touching that, I'm gonna just gently press that in. We got our tip. Now, so long as I don't put this down on the table, this tip is gonna remain sterile. As long as this tip doesn't touch the table, I'm gonna be sterile. So the first step is pressing down to the first resistance, not all the way. I'm going to fully submerge this in the liquid and suck it up. Tapping this on the side, we may want to make sure there's no droplets left. Then I'm going to move this to here, put that on the edge at an angle, slowly press it down, and then push it to the second stop. Wipe this on the rim, and then I've gotten one. I can repeat this. Oh, I want another one in test tube 4. So I put that in after the first resistance. Slowly release the knob, let it suck it up. Put it in, and then slowly press that out all the way. If I want to change the volume, so the second one, maybe at 750, I'm going to slowly, I don't need to go crazy fast, but I can go a little fast, but slowly twist that around. If I twist too fast, it could screw up the gears. So I'm changing that to read 750. Now, this works best when it's in the upper range, so if I was going down to 100 microliters, which is the lower limit, it would be significantly less accurate than, say, at 1,000 microliters. So press it down to the first depression point. Slowly release. Press that in. Fully depress it. I'll do that again on test tube 2 or test tube 5. First point, let it suck up. Press it down slowly and then fully depress it. Let's try 250. So I'll just keep on swinging this down. See, it doesn't need to be fast. We're not in a rush. We want this to work for as long as it can work. Note that the lid has been placed on there to prevent any contamination. And I did not touch the tips with my bare hands. So 250. Press down. Press down. First point. Submerge. Suck. You'll notice it's significantly less. Repeat again. First point and only the first point. Submerge. Pick it up. Make sure I get all those droplets in. Now that I'm fully done, I can move this over to the trash. You'll see the little injector thing. I'm going to press that. It ejects the tip into the garbage. You don't have to touch it. Very important if it's of chemical nature, of like a biological nature. And then finally, what I'll do is I'll store this on a setup like here. So this one isn't really made for it. The idea is that it's stored so to protect the tip, keep that fully safe. That's how you micropipette. In this video, I'm going to show you how to run a dilution. So I'm going to turn a 0.5 molar solution of HCl into something like let's say 50 mils of a 0.23. So to figure this out, I'm going to need M1 V1 equals M2 V2 to figure out if I want 50 mils, what volume am I going to need to dilute to. So starting here, I know I want 0.23. I know the volume I'm shooting for is 50 mils, so I'm going to hit multiply 50. So this is how many millimoles I need to get. And if I'm starting with a 0.5 molar, I'm dividing by 0.5. So that tells me I need to titrate 23 mils to get 0.23 out of 0.5. Now, the next step is to clean a glassware. I've already cleaned these pipettes, so I need to clean this. I'm going to use a little bit of soapy solution. Rinse this. I might be able to find a brush that scrubs this, but I'm just soaping that up. Pouring that out. And then going to fill it with water a couple times. Okay, it's just water. See that there's still suds in there? I'm definitely not done yet. So. Let's do it one more time. Water, since matter. Now, maybe a rinse with deionized water. Notice I'm not necessarily filling this up, just enough that I can cleverly coat the sides. Now, one last thing. If my solvent is anything other than water, I would do a rinse with my solvent now. But since my solvent is water, I can stop with the deionized. Now, the easiest way to get 23 mils, it's obviously too small for a 25 mil pipette, but we want to get the minimum amount of pipetting. So I'm going to use a 15 mil volumetric pipette and then use a 10 mil volumetric pipette, graduated pipette, to get the rest of it. So we're going to twiddle this. So I'm going to suck this up. Get it up to the line. Slowly get in there. Okay, so I need to play with the dial just a bit to get that. Well, up a little bit, up a little bit, down a little. May have to play with it for a minute or two to get it just how you want it. But most of the time when you're doing a basic dilution, time is on your side. So I think I'm happy there. So next step is to put this in the flask and lever the button. I just have to hold this until let it completely drain. Yes, I know it's slow, but it is accurate to do it this way. Instead of trying to purge it by slamming down on the chamber and compressing the chamber, we are just holding that lever and letting it fully drain. Whatever is left is meant to be. Now, next I'm using a more pipette. So, I've added 15. To get 23, I need to add another 8. So I'm going to suck up. I can go ahead and suck up all the way to 10 if I have enough. If not, I do not have enough. So I'm going to have to add more to the beaker. If you have someone helping, it would be best if you hold this erect while they add to the beaker. Otherwise, you can attempt, but it's often much harder because you're trying to hold this to keep the beaker from tipping over. So I can suck up to the 10, or I could suck up to the 2. Suck up to the 0 or suck up to the 2, whichever one, because we're just measuring by difference. So holding that up. So from the 0, I need to let this purge until it's down at the 8. Don't stop it prematurely, but also be very careful so that as I'm holding the button up here, it doesn't shoot past, because it will often drain a little bit more than when you a few seconds after you let go. So the more can be a little bit tricky at times. down at the past the 5, past the 6, past the 7. So here's where I need to slowly tap this. Right at as close to 8 as I can maybe get. If I want to record a slightly different number, say I want to say this is actually 8.99. I could record that and measure my new volume. Okay. Now that I've added the proper amount to this, I have to add deionized water. So add my solvent. So I can add it through here. There's various different methods, but I'm gonna rinse the sides. I can feel free to go fast so long as we are nowhere near that line. But once we approach that neck, we really need to slow down, as it can fill up rather rapidly at that point. And once you've added too much, it's really hard to unadd. So we're going to go with that, and now to the next step. Piece of parafilm wax. So you peel off the backing, and you have essentially a piece of stretchable wax that can seal most aqueous things. You may want to fold it in half. But so what I'm doing is I'm going to stretch this over the entrance so that it forms a tight seal. From there I can then flip that, mix, flip, release that, and if this has essentially decreased in volume at all, we would then re-add. But that is a dilution.